as well as as a first goal, to really develop a diagnostic prognostic blood test. So something as very simple that can be used for clinicians to better stratify patients and eventually use to work towards the selection of therapeutic drug to improve symptoms and eventually cure ME CFS as soon as possible. Okay. So this is a cartoon that just explains to you the different omic approaches. So often we refer to genomics, and this is, as in a very simple term, is what could happen. Okay, and this is already a whole cartoon, so we don't have 40,000 genes. We have closer to 22,000. It's still a lot to watch. Okay, and after that is the transcriptomics. So when we translate the blueprint in something that will lead to the formation of different proteins, so what is often referred at what is happening. Ultimately, we have to look about the protein, and because there's different events that will lead to different form and subtype of protein and modification, so this is probably what is causing at some point ME CFS, like any complex diseases. Okay, but we don't know yet what are the type of the protein, and you may have enough of one protein, but the protein may be at the wrong compartment in the cells. Okay, this protein can go in the nucleus where she should be at the membrane, so there's a lot to explain. And you learn a lot about the metabolomics, so which is either the resulting of whatever is happening during your metabolism, and also those small molecules can have also a feedback effect and may trigger changes as well. So it's not just a hand product, it could be a causal product as well. And you see the complexity, and eventually when we understand clearly what are the good biomarkers, can we develop animal models, so you saw some example. But we don't know yet. We cannot start with animal model without knowing what are the key genes, what are the bad proteins, and how can we manipulate them. So just to add another layer of complexity, not only we have to deal with complex genetics, but also with protein, but everything is also linked with the environment. And for most, if not whole complex disease, we have to take in account this crosstalk between genetics and environment. And the best example that I can share with you is the caterpillar and the butterfly. So you see I'm working in a pediatric hospital, so I have to keep it simple. If you isolate the genomic DNA of the caterpillar and the butterfly, it will be the same genome, more or less. Of course, if you use sophisticated tools, you see more methylation and something probably in the butterfly that can explain why some genes are turned off and why others turn on. But how you become from a caterpillar or butterfly, you're exposed to different temperature changes, luminosity, through the chrysalid, and eventually you become a butterfly. So, very important step. But blindly, if I give you the DNA, you cannot say who is a caterpillar, who is a butterfly. So we cannot just purely and only relate on genomics. We need to address that. And this is particularly important for ME CFS. So, ME CFS, the elephant in the room. So, of course, as a researcher, we have different or favorite part of the elephant. Somebody, even blindly, you will go for the trunk. You can go for the tail. You won't see Dr. Navio on that one because he's already inside the elephant. Okay, to have a closer look on the mitochondria. The take-home message here is we're not flying blindly. The take-home message is we're covering altogether the elephant. This is a premiere, and the last 2 days were very important. We are covering the elephant. But we have to deal with different type of elephants. Okay, so this is why the subtyping, and I have this discussion with Bob. In fact, we should eventually replace the S in CFS, not to use as a syndrome, but spectrum. Probably we will closer to the reality of what is really happening. So I won't be the one that decide that, but eventually we will forge a consensus. And I think that we have to learn from other diseases like autism that make a lot of sense. So how can I manipulate your environment knowing that you may or not have genetic predisposition? So I have several discussions with patients, and this is a test that I have developed with some patients. And I would just say his first name, Christian. Many thanks for your, I know he's watching. Okay, many thanks for your help, okay, and comments. So we developed what I refer to as stress tests. To perform the test, we need to figure out something that will be easy to perform. And 3/4 of the patients that we have tested so far are housebound. So there's no way that they can go in the clinics or go in the lab to do the test. Even that, this is so stressful that they cannot achieve that. So we use what we refer to a therapeutic massage machine, that you have inflatable cuff that apply to one arm and that give you a very gentle pulse. It's certified to do therapeutic massage. So you see 0.006 Hertz with 0 to 4 PSI. It's very therapeutic. But this is, trust me, this is very enough to create a stress. So we did about 200 individuals, and we use also age and sex match control to really establish the value. And we start to measure different molecules, and including also one of my favorite one is the circulating microRNA that I will talk to you in a few seconds. So we start before stimulation and up to 90 minutes. And we draw blood and we keep the cells for different type of assay. So this is the reported side effect following the test from the patient. So 1/3 of the patient have no symptom. We're happy about that because we want to have a safe test, and there's no way that we would like to call 911 every time we have to do the test, because this is the clinical nurse going at home doing the test. But nevertheless, 2/3 of the patients report significant side effects that are connected with ME CFS. I would just give you an example. Mental fogginess, 12% of them, just by receiving a gentle massage. So that's mean a lot. If we go a bit further about, do we develop post-exertional fatigue following the test? Again, 24% patients report no effect. But you see the other one, that severe fatigue exhaustion that may stand for 1, 2, up to 3 days. So the test is really creating a stress. And we think that this is the safest way that we can provide that in a very standardized manner that we can apply to everyone. If I put you to do some exercise on the treadmills with a VO2 max, probably I might have different results depending on your capacity. But this, you lay down, we put the machine, have a nice discussion with the clinical nurse, and the machine is doing the rest, and your body is doing the rest also. So nothing too dangerous that might happen, and we are sure that we can reproduce the test every time. So what we learned from that? First, we look on different biochemical factors. I will just mention one. The colors are for something. So in 20% of the patients, so 1 in 5, the brown one, we saw that higher plasma homocysteine level, so which is a bad molecule, okay, and it's not specific for ME CFS. It's something that we shouldn't have at that level, so 30 micromolars, and that matched the most severely affected ME CFS patients. Secondly, we measure through different questionnaires that indeed those patients have the lower physical capacity and higher post-exertional malaise. What is new is, and that's why I call we rediscover it, is because Rigland 20 years ago paid attention about homocysteine. He found out some elevation in cerebrospinal fluid, but not in the plasma. One of the problems that we encounter is the fact that most of the study, for different reasons, including lack of funding, work on very small cohort. So if you have 20 patients, 1 in 5, so you will have very few patients. You would think that this is abnormal, this is an outlier, I will remove it from my study. So having more than 100 patients, now we start to see something. And for us, it's a good point to start having the most severely affected patient. Now, because some of you may be severely affected, there is no mean or automatic mean that you have high level of homocysteine. So don't go directly to your physicians tomorrow. But it's something that we should pay attention. Because we can work, and there are drugs and diets that can help you to modify your level of homocysteine. So this is something that can be actionable. But we need to be wise and to really understand what are the causes, and this is why we are continue to study that. So high level of homocysteine, and this is a very small chemical entity, is very important because it's connected with different things. You heard that mitochondrial dysfunction, so there is a connection there. There's also a problem with other signaling receptor concentration. So I think it's a molecule that is worth to pay attention, and at least for the most severe one, without knowing the cause of that, we should simply have this biochemical test. We look also for different vitamins as a cofactor because the pathway leading to high level of homocysteine involve different vitamins. We didn't find any lack or deficiency in vitamin even in the most severely affected patient. The only things that we recently, a week ago, is that we find in men with high homocysteine, we find a deficiency in vitamin C. We don't know yet if it's a diet deficiency or if it's in the capacity to transport the vitamin C inside the cells to be used. And there is a strong literature about the link between lack of vitamin C and homocysteine. So we are continuing to exploring that link. So to keep it a simple explanation, we need to figure out if we have mutation in some key metabolizing enzyme that will prevent the degradation of homocysteine, as well as we are looking, especially for the vitamin C, if some key transporter can be mutated and preventing or reducing the capacity to uptake the vitamin C. The third target that I have a lot of interest is the circulating microRNA, because microRNA are small non-coding RNA that can target different genes and prevent the production of proteins. So we find out 32 circulating microRNA, and obviously this kind of what I'm referring to, very colorful carpets, give you just an idea about the changes. So if you look about the first line is ME CFS stimulated 90 minutes compared to control, you see you don't have exactly the same color, so you don't see the same intensity on the expression. So more red is highly expressed, blue is downregulated. So we are looking about that, and of course we are looking at different profile at baseline. Our claims, and this is what we are testing right now on a large-scale validation, is we think that the stress activating, so the one that we see the profile after the stimulation, will reveal more the real events behind the pathophysiology of ME CFS, and that can be highly reproducible as opposed to patients at different baseline level, because patients are coming at different time of the day, they have different diet, they have different profile in terms that early on stage of the disease versus late stage. Sometimes they are using just up to 9 different medications. So it's very hard to really consider all those events. So that's why we need to have a standardized stress test to make a difference and apply the same thing to everyone to see what is the real pictures that we have to deal with. The last part, and some of you are in the room, and I'm very happy to meet you for the first time, because we used to talk by phone and by email, is to study identical twins, but that are discordant for the disease. So one twin is affected, not the other one. And we are looking through a whole exome to the genomic data, and we secure so far 12 couples in the world. So we have people from USA, Canada, Scotland, we are from New Zealand, Australia. So wonderful response, and I just want to thank you to the bottom of my heart to your support. You don't know me, but I'm engaged myself and my team to serve you and to figure out what is wrong with you guys. So many thanks for your trust. Finally, I would like to acknowledge the participant, the patient and your family, the Quebec Association for Myalgic Encephalomyelitis, as well as the national level MEFM and another Action CIND. The last two organizations were very helpful to, at the international level, to organize and recruit those monozygotic or identical twins for that part of the study. And also, I would like to thank my team members, the working bees. So without them, I won't be here today to share with you what we are doing. So again, many thanks for you listening this beginning of something nice story. Thank you.
Thank you very much, Alain. That was, I'm really glad you managed to connect with some more twins. These studies will be very interesting. So I'm happy to invite our second last speaker of the day, a collaborator of ours who we've had a lot of fun working with and who is going to talk about something I think is everybody's pretty excited about, judging from the questions that have come even before his talk about some of this.